Hey, hi everyone. Welcome to our fifth lecture of CS101. Hope you guys doing well for the first one and a 1 month and a week of school. Yeah, I know it's gonna harder and harder, but I hope you guys doing well. So today we're gonna talk about higher order function. Higher order function is a bit special because it does not have corresponding material in DVC C++ courses. Yeah, but we're gonna figure it out very soon. So let's get started. Um, the study goal is what objects can a Python function return, and what is a higher order function, of course, and how can higher order function present in an environmental diagram? With function carrying, function abstraction, and a decorate function. So we have lots of to cover today. So the first thing is to return the function as a value. Um, so what do you know? How many stuff do you know like Python can return? Python function can return. So we know that we have numbers, we have integer or floating point numbers, and we also have a string and also Boolean value, like basically true or false, and also a function. So a function can be returned as a value in Python. A function can be returned from another function. So it's like basically everything you know so far. So think about this code right here. So we have defined test1, return x squared, and define test2, x return test1, and a is test2, a and a is a2. Like it's weird here, right? Because you can have a variable which can be called. Yeah, like only functions can be called in codes, of course. So let's see. What object is the variable named a binding with? So we see the a equals like assignment line. We see a equals test 2, 8. So we have the function call, we open up the function frame, and we passed 8 into the function test2, and then we return test1. So it's a test1. Test1 is a function, like it's a function name in this code. And you see here return test1, which is a function name. So that means that I return this function and bind treat the function as a value and bind this value to the variable a. So which means a is a function of the function test1. And what is the object variable named b binding with? So we see b is a2. Is a function? Let's see what a is. So we find a is test1. So we like which is bound to test1. So we pass 2 into test1 and return 4. So it's an integer. So what are the parent frames of the function test1, test2, and 8? And a, like because they're all functions and they must have their parent frames. So test1 is defined like at the very outside frame, which is global frame. So its parent frame is global frame, and test2 same. And what about a? A is test1. So test1 is defined at global frame. So the parent frame of test1 is global frame. So of course a is test1. So the parent frame of a is also global frame. So they're all global frame. They're all defined in global frame. So the parents are all global frame. Yeah. So yeah. Any questions about this code? Okay, so a summary of this is like you return a function as a value in Python. So a function is a value which can be returned by another function. And this is the fundamental theory of why higher order function can exist. So in other words, like this is the fundamental theorem of what our content can be meaningful, can make sense to like today. Like we are going to talk about higher function. Why is it making sense? Why is it meaningful? Because you can return the function as a value. So this is very important. And another thing is return function as an object. A function is an object in Python. Like I don't know about C++, but Python in Python, a function is an object. So um, having this a few definitions and explanations. Let's dive into the higher order function. So higher order function returns the function as a value. So to be honest, they are just like nested functions, which means that there's a function and there's another function inside the function, and the outside function, once it gets called, it returns the inside function to where the outer function is called. So let's see, we have an example, define multiple. So we have define multiple. We also have another function called define mul. So this is the function nested. This is the inside function nested in the outside function. So the mul x is inside and multiple is outside. And we have a function definition, like define function and then return something. And at the end, we have return mul x. Like mul x is just a function nested inside the multiple function. So they're just nested functions. And also the outer function return the inner function. Yeah. In the parent frame of the inside function is the frame that created by the outside function. So which means that the parent frame of mul x is the frame created by the multiple function, like one of the calls. So yeah. And the outside function returns the function inside frame. Like see, we have the function name here, so we return this name. So how's it gonna, like how the program runs the higher order function? So let's talk about it in our next slide. So to understand the code, like we use also in random diagram. So we know this is like all this is global frame, and this is the codes inside the function multiple. So these codes they are defined in the frame one created by multiple this function. And like when you get multiple like mul x called, you also run this function. So basically we have like kind of three sets of codes. We can divide it into three sets of codes. So we're gonna run one by one, like from the very outer to the inner side. So this is how it basically is doing. So understanding code, we have defined multiple x, and we know about like according to the inverted diagram knowledge you've learned, and the define like in global frame, if we don't get the function called, so we recognize the function definition, then we skip. So we recognize that define multiple x is a function definition, and that's it. So we don't call the function, and we like skip the whole function definition, and then we hit the A. So recognize this is a function, and then we skip, and we are about to execute A equals multiple 2. So we get a function called multiple 2. So we open the frame created by multiple, and then we pass 2 into X in the frame 1. So we already know like, oh, and then we create the frame 1, and we pass in X equals 2 into the multiple function. And then we still have the function definition, and then we recognize it, and then we skip it. So we recognize this is the function multiple mul x, and we recognize this is a function, and parent frame is global. Oh, sorry, is f1. So because it's defined in this function, so the parent frame should be the frame created by the outer function, which is multiple. So we're going to return something. So what's the return? Return the function, like because we treat function as a value, is returnable. So we return the function, as a value, and then bind the function to the variable a. And then we know a is multiple x, and the parent frame is f1. And then we continue executing B. So B is A of 5. What is A? A is the function mul x. So we pass in 5 into mul x function. So it's F1. So it's having F2 created by the mul x function. So so this time we have tried to execute the code inside the mul x function, and we pass in 5 into y as y into the mul x function. So let's see what is the difference between F1 and F2. Like they have different parent frame. The parent frame of F2 is F1. The parent frame of F1 is global, and we have y equals 5. And then recognize x is 3, so we return 5 times 3. So it's 15. Return 15. Okay, so we bind the value b to the return value 15 because like the function call is called here, and this bound value return value to b, and then we have b is 15. So let's do demonstration of it. Turn off. Yeah. So we have defined multiple. Like everything executes from the global frame. It's the very, very outer frame. So we have defined multiple function definition, recognize it and we skip it. Yeah. And then we have A equals multiple 2. Multiple is a function, so we basically have a function call and call to multiple. And we pass in 2 as x into this function, multiple. So multiple x is 2. And then like we're still having F1. So we know about this is mul x is a function definition. So we recognize it and skip it also. Yeah. So so we recognize it's a function mul x, y, and parent is F1. And then the last one is return mul x. So return the function, return the inner function, mul x. And we finish calling multiple function. So return the function as a value and bind the function object to A. Yeah. And then we are having B is A of 5. We call A is function, is callable. So A is the function mul x. So we pass in 5 into mul x and let y equals to 5. So we call the function mul x, but parent frame is F1. So y is 5. Then x is 3. Like we're executing the codes inside the mul x function, and then x is 3. So return 5 times 3 is 15. So we bind the value 15 to b. Yeah. Okay. So any questions and comments about executing the example of higher order function? Yeah. Okay. Let's move on. So we practice with the code. We just do very short explanation of it. Like we have the instant code. Like for example, when you run this code and you type this thing into the terminal function, the terminal. So we get b equals function 1 or 3. So let's try to see what b is. So b, let's see, a is 5 and define like we recognize the function and then because it's a definition and then we skip. So suppose we have b of function 1 3. So we pass into 3 into function 1. So function 1 is we have x is 3 and a is also 3. And then we have the function definition, recognize it, and we skip, and then we're going to return. Okay, we return function 2. What's a function 2? Function 2 is a function. So we let b bind to the return value, which is a function. So b is a function object. Yeah. And then we have c equals to b of 3. So b is a function. each function is function 2. So we pass into 3 into function 2. So function 2 is basically in F2. Oh, wait. Function 1 is F1. So all this is only hit the definition, and it doesn't execute the codes in the function 2. So the outside until this is global frame, and this is frame 1, and this is frame 2. So we pass into C is B of 3, and F1, the parent of F1 is back to global, and P is F1 for F2. So C goes to P of F3. So we pass into 3 into this function, and then we return A times X times Y. So with something times 3. So what's X? Oh, X is like we do not find the X variable in frame 2. So which means we have to look it up in the global frame. Sorry, in the parent frame. So in parent frame is F1. So F1 is function 1 is X, and we pass in the value 3 before. So X is 3, so 3, and A is also in frame 1, so A is 3. So we have 27. Yeah, C is 27, and then B of 6. Okay, so let's do it. So this is like global, and this is F1, this is F2. So P of F1 is global, and P of F2 is F1. So D is P of 6. So pass in value 6 into here. So because A and X doesn't they do not change. So we have 3 times 3 times 6. So I guess it's 54. Like, yeah, 54. Okay. And then we have A. So notice that like everything type in the global is everything type in terminal is global, is in the global frame. So we have A is 3 and A is 5 here. So which one we choose? We choose this one. Yeah, because terminal is in global frame. So this 5. Okay, so I think I have demonstration of it. Yeah. So mhm. Okay, so we start from A equals 5, and then define function 1. We recognize a function and skip it, and like it's a function object, parent is global. So B, so we call function 1, and we pass 3 into function 1 and creates a new frame F1. So F1 parent is global and X is 3. Then A is 3. Then we also recognize a function definition. We know it's a function definition. We do not call that, and we skip that. Function 2, and we just return function 2. So we return the value function as a value and bind the value to B. So B is the function func2. So return func2, then bind the value B, variable B to function 2. And then we have C. C is B of 3. Like so we pass 3 into B. B is func1. Oh, sorry. B is func2. Like we have the association. So 3, we pass in Y, and then we get Y is 3. So this is a function called func2. Func2 is like B is func2. So we find what is A, what is X. So we find it in global in our parent frame. So we have A is 3, global frame. Oh, sorry, parent frame. Sorry, parent frame. So A is 3, X is 3, so Y is 3. So we combine, we get 27. Return 27, and then bind the value to C. C is 27. Then we got D. This B. We pass that into func2. another new frame 3, y6, and x and a, they are still all free. So we get 54. We bind the value 54 to variable d. So you're done. Yeah. So any questions about this one? Any questions about how to run this higher order function example? So higher order function is like this. So we have defined a function, and then we have another function nested into the function. And then for the outer function, it returns the inside function to the variable. Yeah. And then once the inner function gets called, the parent frame will be the frame created by fun1. Yeah. Okay, so let's move on. Function curry. So think about curry. Curry is a famous food from Southern Asia. So yeah, curry is a food, but we do not talk about food today, since function currying is another total different thing in Python. So function currying is like the inside function also has a nested function with a frame created by it. And then which is the example is like I already have if I f1 and then suppose it's x and we define f to y and then blah blah, like we still have to return f2, right? It's a function. But for the inside function, we also have a nested function. So say define f3. I see. So so we still do something. Let's say like return receive, and then we still return f3. Yeah. So this is high order function like function currying. This is like a very strong higher order function. Like when we have the inside function, it also has a nested function in it, and then so you basically have at least 3 functions to create a function currying. So function currying is like the very outer function is a higher order function, and the middle function, like which means that the nested function in the very outer function is also a higher order function, and so on and so on and so far. And we get multiple higher order functions together, like one in another, and then we still do return, even though it's like is an SD function, is an inner function of the very outer function, but it still return the function inside of very inside of this nested function. So this is function carrying. So in other words, there must be at least 3 functions, and the function is nested in previous function. The outer function returns the inside function at the very end. Yeah. So this is an example. Define 1x, define 2y, define function 3, c, and I do like they both multiples together, and then return function 3, return function 2. Yeah, so this is an example of higher order function, and we have a demonstration of how that works. Yeah. Oh. So let's say A is function 1, B is A of 3, C is B of 4. Okay, so we have function definition skip, and then A is function 1, pass in 2, create a function called f1, and we pass in 2 as x. And then we have function 2, function definition skip, then return function 2. So return function 2 is a value, bind the value to A. So A is function 2. A is function 2. Then B is A of 3. So B calls function 2, and then passing 3 into function 2. Function 2 is in the parent frame is in f1. And the F2 is like passing value 3 into Y. That Y becomes 3. And then we have the function definition func3. We skip and then return function 3. Yeah. And bind the value B to function 3. Oh, another function. So yeah. So B is function 3. And then C is B of 4. Maybe there's another function, like nesty function. And maybe let's try it again. We have C is 4. And then in this frame, we finally found, oh, we return integer. So we have C is 4. What's Y? Let's see in the parent frame. Parent frame is F2. So looking up in F2. So we have Y is 3. What is X? We can't find X in either of them. So we have in F1. Like parent frame of F2 is F1. And then we get X is 2. So X times Y times Z is 2 times 3 times 4. So it's 24. I think that's 24, yeah. So return 24 and then bind the value 24 to C. So it's done. Yeah. So this is how the function this is how function calling runs. So A is func1 2. So it's the function func2 function object. B also a function object though, like because A is function 2 and returns function 3. Yeah. So function and C maybe there's another function. Not really. Like I get return here. So it's 24. Yeah. The structure of function carrying is like a hurricane though. Like suppose this is a function carrying, and then we have global variable outside of the hurricane. And then we have the very basic, very strong function carrying. And then we have the first function definition, very outer function, and then nested function, nested function. When you call, if you want to like, the structure is like we still have a lot of returns. So we return function in the function, very nested function and the less nested function, and then return like a value or something. Like okay, so it's like this is function 1, function 2, and function 3. So the structure is like for this, it should be like something like maybe an integer or boolean value from the very nasty, very the bottom nasty function. Like it's been protected very well, kind of. And then when you want to like you call the function and you only get this. So it's another function. And you call the inner function, you also get the return of the another function like the nesty function. Yeah, so once you call the same function step by step, the structure deeper and deeper, so you get the final answer. So this is the structure of function carrying. Yeah. So okay, functional abstraction. So you treat function as a tool. Uh, this is the basic concept of functional abstraction. It's like suppose you have something but you don't know how to do, and then you borrow a tool and you just use the tool as what it says on the instructions. So and then you achieve your goal. Like you don't have to build something. Like you just simply know, oh, this is a tool and it can help me finish something, and then you use it without knowing how that actually works. Yeah. So for example, when you multiple 4 and 6, like um, just know like, oh, 6 times 4, it returns, I only need to know it returns 24 without knowing how multiplication works. Yeah. So this is the meaning of the two. Like you don't have to know how they work, you just know the answer. You just need to know the answer. And the function as a value, like function can be returned by another function and can be also taken into other functions as arguments, because function is a value in Python. It can be taken into another function. It can be returned by the first function, something that can be returned, can be taken into a function. Yeah. And then function as an object. A function is an object in Python, like as shown in the environmental diagram. So we know a function is an object. So it's an example of functional abstraction. So define, like suppose I want to build a calculator. Like I have the functions like add, mul, and sub, like addition, multiplication, subtraction. Yeah. So we have f(ab) returns f of ab. So f is actually a function here. So you can call the function and turn the ab into the argument of the function taken into this. So this is what I mean by treat function as a value, and so that you can take the function into another function as an argument. So this is a function taken into it. Yeah. So suppose I have x is calculator, add 1, 2. So basically, y is calculator, mul 2, 3. So you have x. So like according to the calculator here, it's like add 1, 2. So you just bring it into the function. So you return 3. And you have y, calculator, and mul 2, 3. So it's basically the same. Mul 2, 3. So you take it into the function, you get 6. Yeah. Okay. This is how functional abstraction works. Like you treat function as a value, so that you can take the function into another function as the new function's argument, or you treat it as a two without actually knowing how that actually works. You just know, oh, you can return the right answer I want. So this is functional abstraction. Yeah. And we have decorate functions. What's the decorate function? It's like decorator, like if you try to decorate your try to design something, design a website, for example, like to calculate, to as an online calculator, but you still want to input something like some beautiful pictures, maybe how beautiful the Pacific Ocean is, and then you put the picture of Pacific Ocean into it, um, or saying like, oh, this is the ocean of math and something, or it's like you try to display something like when you pass in 2 and 3, you want to show in the output is like I pass into 2 and 3 into the output. Like it does not actually affect the function running, but it's kind of like doing something like decorating. So decorate function is like functions pass into another function. So we'll see the example later, but you just see like it's just decorate the function, like the decorate function is used to decorate other functions. So we call that decorator. The decorate functions, we call decorate functions as decorators. So basically, like decorate functions come with an add operator. Decorate functions are functions passed into a function. When the pass function is called, you run decorate O. I will see the example very soon though. Don't worry. Yeah. Basically, decorate functions is the shell of the passed function. Okay. Like decorator. Okay, here we go. So we have decorate function, and we have inner function and then return. And this is the decorate functions. Like I have the add operator, and then you have define decorator function, like take in a function. Let's see, define inner, and then you print something, and then you return the result of the function you pass in, and also the inner function values, and then you return the inner function. Oh, This is kind of complicated. Oh, so what functions will the decorate function pass in? I have the decorators here at decorate with the function decorate function name. So we define multiple AB returns A times B. So like although it's kind of abstract, but we pass in the multiple function into the decorate function. So it's like when you try to run the multiple function, if you run the shell first and then you return the value from here. Yeah, so return the value like you have the function call and then you return the output of this function to here. And before having that, like maybe you have to print something first and then you return your output. So how that works is like this is a decorate function. We don't actually call the decorate function directly. We usually just call multiple function, and we have A and B. We put that into the decorate function, and we run the decorate function. So we put into the function here, and then um, I return the inner. I have function definition and return the inner, and then I will run the inner function. So run the inner function inner AB. So A is just the AB of this multiple function. And I will print number A and the value of A, number B and the value of B, and then I'll return it. And from here, we actually start executing the function we passed in by return func AB, right? Because we made a function call to it. So suppose I have A is 2 and B is 3. When I call multiple function, it will still like run decorate function first, and then you print number A 2, number B 3, and then you return 6 as an output. Suppose I have multiple 2, 3, and then use output number A to number B 3 first, and then you return 6. You have 6 display here. Like this is the print information and this is the value returned. If you're interested about how decorators work, you just read about this after class. The more reading about decorators. So I can run the decorate function for you guys. Yeah. Okay. So let's see. So decorate function is here. So we have decorate function. I'll just call multiple. Multiply 2, 3. You can, maybe I will try 105. Yeah. Okay, you display like you will run the inner function. We still have print first, and then return. From return, we actually try like start executing the function we want to execute. Like apart from that, everything is just decorators. Yeah, it is unnecessary. Um, So number A 100, number B 5, like is printed out to show you guys, oh, it's very explicit. Like I pass in these values, and then I return this value. But the thing is like, why decorate function can exist is the same as high order function. Is like, you can pass in the function into another function as an argument, and then you still return the inner function. This is why decorate functions exist and make sense. Same as higher order function. And decorate function itself is in the structure of higher order function too. So I can also try the calculate function. Yeah. So calculator. we have mile, and 5, 8, 40. Like we pass in the value, pass in the function mile as a value into calculator, and then we call this function. Yeah, like in I think in Python and or in C++, uh, functions are the only thing that is callable. Like when you say a function, a thing is callable, you say like this can be called. Like usually only functions can be callable. So if you type something like, so if you type something not a function, it will display an arrow saying like this is not callable. Means that this is not a function. Yeah. Okay. So the last page, I will give you guys like 10 minutes to try drawing the higher order function. Yeah. Or 15 minutes. Let's try drawing the environmental diagram of the following codes. Like, so let's have 15 minutes to draw the environmental diagram of this code below. Okay, so we will talk about it in 15 minutes. So it's like 56, 856. Okay, let's try. The answer is 17. Like, um, yeah, to sure, you sure your answer is 17. Oh, 16. Wait, the answer is 16. Sorry. Sorry about the wrong answer. Oh, yeah, I still have 3 minutes left. Yeah. Okay, yeah, the answer is 16, and now we're going to figure that out and go for every step of it. Okay, so how are you guys doing for this? Like, something is new here because we have a high order function. But it's okay. We just based on what friends we are, every time we look back to our codes and just do it step by step. It's okay. And let's try like first we have global frame. So A is 1, B is 3, and then func1 is function object. Um, Parents is global. Yeah. And then lambda, like we have it, the function definition, and then we skip it until we get the lambda. Is lambda function. Usually our write is in line 11. Parent is global. Yeah. It's basically AP though. And then we have solution. The first solution is like we call lambda BA. So let's try it, like because it's the first function call we have it right here. So we have lambda AB, parent is global. What is A and B? So A and B is just the reverse of B and A of the global frame. So um, A is the B on global frame, which is 3. And B in lambda is A on the global frame, so it's 1. Yeah, 8. And then you're gonna return, like usually just return this thing. So this is a function call. Oh my god. So gonna have another function call, but don't worry, like it's not that hard. Uh, function 1 parent is global, and then we pass in still xy, I think. Yeah, it's xy. And then xy in function 1 is just a and b in lambda. So x is 3, y is 1. And then a. Here's a new a from frame 2. So a is 2. So a is 2. And then let's see. Oh, so we have a. We have the function definition, and then we return the function 2. So function 2, function object, fun2, parent equals f1. Yeah, this is very important. It's defined from 1. And then return value. Return value is just function 2, like because I returned this. So and then we return function 2 to where? To where the function 1 is called. Where the function 1 is called is in lambda. So lambda also return this function 2. So return value same. And also solution 1 same. Yeah. And then you gotta have solution 2, which is the last one, last variable on global frame. So we pass in solution 5 into solution. You pass 5 into the solution function. Solution function is function object, func2. So you open a new frame, F3. Func2 though. Yeah. Func2 parent is F1. Yeah, don't make errors. Is F1 because the function func2 is defined in F1. Okay. So we pass in x inside. X is 5. And then the next one is y. Y is x plus 1. Y is 6. And then what is going to next? Oh, return a plus b plus x plus y. Okay, return value a plus b plus is x plus y below 6 plus 5. Yeah, so what is a and b? So we know x, y is 5 and 6, and then we know a and b. We don't know a and b because it's not in our frame. We can't find a and b in our frame 3. So we'll return to the parent frame, which is f1. So return to f1. You see, oh, a and b is 3 and 1. Okay. Oh, sorry. We don't have it's not in f1, it's in f2. Oh, sorry guys, I made an error here. So because fun2 is defined in fun1, and fun1 is actually f2. Yeah, it's actually f2. Um, sorry about that. And then we have f2. So we have a is 2. We still can't find b. Like we don't look into f1 because the parent frame of f2 is global. So um, we should find b variable in global frame, not in frame 1. Yeah, so we go to frame global frame, we find b is 3, and then we know, okay, 3. So it's 10 plus 16. So return value is 16. Uh, so return to solution 2, which is 16. So this is the answer. Yeah. And the demonstration. So it's like, yeah, we started global frame. A is 1, B is 3. Yeah. And then define func1. The function definition, recognize, skip. Yeah. And then we have lambda, recognize, skip. Then solution. Solution is lambda AB. We call the function. So it creates F1. So we pass in A is 3. Yeah, and B is 1. So we just do the opposite of A and B on global frame. And then we have to return func1, but it's a function call. So we opens frame 2. Frame 2 is function created by function 1. So we pass in xy to be 3, 1. Yeah, and then A is 2. Yeah. And then function definition, recognize, skip. Yeah, so it's function 2 and object. Yeah. And then return function 2. Return value is function 2. And where are we gonna return to? Return to lambda. Yeah. And what are we going to return from lambda? To solution, the variable solution. So solution is bound to a function func2. So then solution is done. So we do solution 2. Solution 2 is solution of 5. So we pass in 5 into solution, which is func2 function. And then we create another function frame, f3. So it's created by function 2, and the parent frame is function is f2 because function 2 is defined in function 1. Yeah, and then we do the function frame. So this is the parent frame of the function 2 of f3. So we have x is 5, and then y is 6. Yeah, and then return the stuff. So we know x and y, and we should know a and b. So return to the parent frame. Parent frame is f2. So I only get a here. So still look into global and then see, oh, I got b eventually here. We skip f1 because f1 is not the parent frame of f2 here. The parent frame of f2 is global. So we have b is 3, a is 2, x and y is, they are 5 and 6. So we get 16. Yeah. So return 16 to solution 2 variable. So there we go. We are done running this course. Okay. Hopefully you learned about high order function in this course, in this class, right? The fundamental theorem of high order function is that high order function, you can return a function you can return a function from another function. So you can make a variable bound to a function because function is a value in Python and it's also an object in Python. So which means that as a value, you can take the function into the another function's argument. So you can take in as a value to another function, which is very flexible. Yeah. And function carrying is like there are multiple high order functions going together. Like usually some very simple basic high order functions like we only have one nested function inside the function, and then we return the nested function. But for function carrying, we have a lot of nested. So in order to get the very inside one, the basic, the bottom one, we have to call all these again, which is like yeah, which is like you are cooking with onions, like you have to take out of the skin a lot of until you get a core. Yeah. So this one is like function one, function two, function three, and you return something from function three, and you return function two, and then you return function three, and then you return function two. This is like the structure of function carrying. So and for functional abstraction, I treat the function as tool, as a value, and as an object. So as a tool is like you don't have to know how that works. You just like take in and return some output that you think that you want to, and you know what the output is. And the value and the object can be taken into a function and be returned by a function. Yeah. And decorative function is the shell of the taking function. The shell, like when you actually run the function taken into, it returns something like some decorations first, and then return what you want to get. Return the true output, the authentic output. Yeah. So that's it for this course. Sorry, that's it for this lesson of this week. Hopefully you learned about high order function and the fundamental theorem of the high order function, and then use it for some other purposes. Okay. Hope you have a wonderful week. Yeah. See you.
Thank you.
Yeah, you're
Bye-bye.
welcome. Bye-bye.